Okay, that's a recording and the transcription started, and I'll make those available later. And as I said, this is our Labture, and that's a word I'm going to keep using until everybody uses it, so please join in, otherwise it just makes me sound silly. So again, the idea is supplying the materials in advance, letting you work through them, and then asking questions during our labs hasn't really been working for everybody. I know that some people are okay with it, but some people find it really tricky. So what we're going to try and do is during these online ones, we're going to work through the materials, give you the chance to question them, to go into further detail, to do whatever you want. So it'll be a combination of going through the lectures themselves. I've got VS Code running in the background too. So if code comes up, my plan is to actually type in some code, see what happens. But as I say, none of this works unless you actually ask questions, interact, whatever. I'm not doing this just to shout into a void. So as questions come up, as you have issues, just talk. Now, clearly, I'm not going to go all the way back to T1 and start from there. But what I'm going to do is go back to the start of T2.
And now for something completely different.
Welcome along to this next lecture on Python programming. Now today we're going to be looking at things very
it turns
slightly
out that
differently.
I have loaded the one with the commentary rather than the one without the commentary. You may have noticed. Everything is going wrong this morning. I'm going really well. So let me try that again. Let me try it without a commentary, if I can. Much as I like hearing from Jerry, I don't want him to talk over me or vice versa. So we shall try that again.
And now for something completely different.
Okay, so as I said, I'm not going to start again from T1, but I will start with T2 because we moved on to object-oriented programming. So it's a good place to start, and it's also slightly different from what we've done before, because what we've been doing up until now is basically working in a linear fashion. Tell Python to do something, it does it. Did it do it? Yes. Okay, tell it to do something else. Did it do it? Yeah. And we just sort of kept adding on, working in this linear fashion, adding in more and more commands. But in essence, it just did one after the other. That's called procedural programming. And it's perfectly valid. It's a perfectly good way to work. And people still do it and have done it for decades. But there are other ways to work. And one of the ways to work is called object-oriented programming. And part of the reason I started with those pictures and asked you what they were was to remind you that actually you understand what things are, not because there's been some line in Python that says Fido becomes dog. You just look at that dog and know it's a dog. And it doesn't matter whether it was white, black, big, small, fluffy, sleek, irritating. It really doesn't matter. You still knew it was a dog. And that's what we're going to try and emulate in our programming. We're going to try and emulate real life objects.
Can I ask?
And of course.
A procedural programming, it's programming when we just type commands like print something or use some loops. Yes, so it's opposite to object-oriented programming.
Yeah, so for procedural, we are thinking of the idea where we do something. Oops, hang on. We do something, and then we do the next thing, and then we do the next thing. Occasionally, the thing that we do is in a function somewhere, and we call the function, but it still does it in line 1, line 2, line 3, line 4, and it just works its way through. That's not how we're going to do it now. Object-oriented works in a different way. You will still see commands and they'll still work in order at times, but it's a different way of thinking about things. As I said, we're trying to think about what the objects are. Does that make sense, Michaela?
Yes, thank you.
Okay. So what we're trying to do is not so much give commands. What we're trying to do is describe the object and then allow it to do whatever the object thinks it should do. So if I say to you, calculate the area of that. Now, you might have a problem on your screen because it might be squashed, but that actually is a perfect circle. If I ask you to calculate the area of that circle, I don't need to say calculate the area of that circle. I just say go and calculate the area. At which point you go, okay, it's a circle. I will look up the equation to calculate the area, pi r squared, and then I'll calculate it. Or if I give you a square, or if I give you an equilateral triangle, or any other shape, I don't say calculate the area of that triangle. I just say calculate the area. And you know to use different formulas for the circle, the square, and the triangle. And again, that's what we're trying to emulate here in object-oriented programming. We're not just trying to describe the objects, we're trying to make them smart about what they do. So if we set up an object that's a circle and we ask it how big it is, it knows that that's a different question to setting up a square and then asking it how big it is, at least in terms of how we calculate it. So that's what we're trying to do. We're trying to describe objects as they would be in the real world. And to do that, we describe them. So there's the dog, and we might have particular states that it's in. The dog has a name, or a colour, or a type, an Alsatian, or Yorkie, or whatever. So it has things about it. So it is a dog, and these are all dogs, but we can describe them in different ways with colours and ear size and all that kind of stuff. And we can also describe what it is we want them to do. Jump, snarl, look stupid. It really doesn't matter. We can set it up to say, do this. Bark, wag your tail, go eat, whatever it happens to be. So again, we are trying to emulate that in software, to emulate what happens in the real world. So these things, the states, we call attributes, and the behaviors we call methods. So when you set up objects that have things that describe them, the attributes, and things that they do, they're methods. Okay, so far? So, an object is a model. And once we set up that model, we can create as many instances of that model as we want. We can set up a dog and say, this dog is white and happy. This dog is black and quizzical. This dog is black and white and stupid. Whatever it happens to be, but they're all this instances of the same object. They're all instances of dog in exactly the same way as when I brought up these pictures, you all went, well, they're dogs. Even though they all look very different and they're all doing very different things, they're all just dogs. That's what we're trying to do here. So to do that, as I say, we will have attributes that describe that particular dog and methods, things that we're going to make that dog do. So the object is a blueprint. This describes all dogs, and an instance is a specific dog. So we set up the model, and then we create a new variable made up of a copy of that model, and then we can set what we want in it. So let's do a grinding change of gear. And that was deliberate because what I want to do is set up a model of a car, which is why we also had cars when I first came in here. And again, you saw all these things and you had no trouble telling me that they were cars, even though they're different colours, different shapes. So let's start to think about how we do that. Let's start to think about how we define what a car is. So the first thing we do is tell Python that that's what we're going to do. And the key word that we're using for that is something called class. So we have a class of objects. So the class is a particular type of object: dogs, cats, cars. Doesn't matter. We define a blueprint called a class. And I'm just going to call this a car. Red wavy line. What's the issue here? Why is it unhappy? What do we usually have to have whenever we're doing something?
I'm not sure about English word, but yeah, it's probably colon.
It is a colon. So again, we've done this, we've seen that in a few types of Python. So we've got a colon to say, right, okay, so this is the thing, and now we're going to define it, and we've also indented it in the same way as we always have. Now, the first thing that we have to do is define our car. So we define it. And when we're setting it up, another name for setting up is initializing. So we have to initialize our car. And we will send a few things that make this car unique. It could be the registration number, or the colour, or the make, or model.
Self.
I'll get there. So in the same way as we can set up a function and send things to it, we're doing that with our class. We're sending the information to this object to say, my car becomes a car with the registration AB12XYZ. It's
Can I
going
ask?
to be, you can always ask.
When we define a class, the name of the class should be uppercase or lowercase. How should it be written?
Like with most things in Python, it will accept both, but the convention is to have it as a lowercase.
If the class name consists of two names, for example, car change, I don't know, we will write it car how should we write it? Like
So I think what you're
with
saying is so I've written my car there. That's called camel case.
yeah.
Some people, I think probably the most now, use that where they put an underscore between them and say my car.
Mhm.
Some people don't even put the underscore and just say my car. I hate that because that's really hard to tell. So I happen to like camel case. It's simply something I've used for a long time and I'm used to it. Most people now, and certainly people that come from a C background, use the underscore. My underscore car. Python will accept either. The only thing, has my camera gone off now? Can you guys see me?
Yes, I
It's not
see.
showing on my screen. This is weird.
Yep.
The one thing that you do have to be is consistent. So you can't use both of these and expect Python to understand. They are different things. So however you choose to do it, be consistent. As I say, I happen to like camel case. Most other people don't, and they use this one. So I'll leave it up to you. But there's no rule that says you have to do one way or the other. Okay?
Okay. Yeah. Okay.
Okay, so in the same way as we would run a function and send values to the function, this, instead of being a function, is called a method, but it's the same idea. We're going to do things. And just as we would have done in a method, we forgot our colon again. So what we're going to do, we're going to say that my car, and then the attribute is identified with a dot again. My car dot registration becomes registration. So the registration that we send becomes the new registration of my car. Anybody get any issues with that code?
I have one.
Mm-hmm.
We didn't pass the self in the init function. That
And
might
what's
cause some
self
problems.
when it's at home?
Pardon?
What is self?
Self is a part of the init function that basically does all of the elements for us. Once we make, let's say, a new variable, it will be the local variable that the class sees, self.variable.
Yeah, it invisibly passes a reference from the particular object to the class, that the class could know what is the object he deals with.
So what they're saying is, I have put in here my car dot registration, which works fine for my car, but what if it's your car? Clearly that doesn't help here. So you have to pass whichever variable you're setting up to the initialization. And the keyword that Python uses is self. So instead of saying my car, we say self. Whichever variable we are setting up, set that one. And if it's my car, it's my car.registration. And if it's your car, it's your car.registration, and so on. And that's us. We can then continue doing our initialization. The color of the variable that we pass, self.color, becomes the color that we've passed. The color of the variable that we've passed in, sorry, the make of the variable that we've passed in becomes the make that we've passed in. And the model of the variable that we've passed in becomes the model that we've passed. Now, I don't know if you can see it, don't know how well it's coming over. VS Code has a nice feature. Don't know if you can see it up there. Can you see that make and model are two different colours there? Or a dark blue and a light blue. What it's saying is, you've passed this and you never use it. So watch as I use it. And it suddenly becomes dark blue to say, okay, so you've passed this in and you're using it. I am happy. There's nothing wrong. You could pass it and it wouldn't generate an error as such, but it's not very good to do. So that's us. We've defined a car. We've defined its attributes, and we can then set that up. And I'll quickly, sorry?
Can I ask? We pass 4 parameters, and how are they assigned to arguments in it, like in the function or differently? So, for example, blue will assign to the color or to the make, like.
Okay, so we've got two different variables here, and the issue that we have is, to our eyes, they are the same. Registration becomes registration. Color becomes color. And that feels kind of weird. But they're actually clearly two very different variables, and the key is in the dot. So it's my car's color. So my car dot color becomes the color that we pass this thing in text. And it's sometimes when you get started with this, it can be tricky to try and remember that, but that's what it's meaning. Even though we've used the same name, they are two different variables. The my car dot color, in this case blue, or your car dot color, which is red.
I mean, are they assigned like positional parameters to the arguments, or so if I pass blue, will it automatically assign to?
They're in order in terms of how you've defined them in the init function. Yes. So you have to send them in that order.
Mm-hmm. Yeah. Okay. I see.
So
Thank you.
we have an object that we've defined. We've got some variables that we've set up that are those kinds of objects. Now we can do it with them as we normally do. I'm just going to print them out. So let's run it, see what happens. Ah, rats. It's gone wrong immediately. Nikita?
Yeah, I have a small question according to the variables here, self, color, color, let's say. Is there any chance of renaming the right part of the variable and it would still work in this class? Let's say self.color would be red, and then we work with the red part. Or we have to specifically name the variables the same, self.color equals color.
No, you could say self dot hue becomes color.
Mm-hmm. And then
Self
the
dot
self hue is the one that we are working with, or it's the color that we are working with.
no, it's the whatever is in self. So now instead of attributes called color and make, we now have attributes called hue and manufacturer. And if we want to access them, that's what we have to say. So that's what they are called now.
Mm-hmm. Perfect.
So we've used them with the same name. Just, I think Jerry's trying to make it clear. I'm not entirely sure that always does make it clear. So I'm just going to leave them like that now, actually. We'll have them as hue and manufacturer. Okay, so there was an error here. Yes, I'm looking at the chat, so try not to and tell me what the issue is with the code. Whoops. What's the issue with that code? Judging by that error. Type error, car takes no arguments. An argument is the information in the brackets that we're passing to and from. So what's the issue here? Nikita, your hand's still up. I don't know if you want to come back in or if it's a legacy hand.
Sorry.
Okay. Mohammed had it ages ago. One of the things you have to be careful of is the init function has got 2 underscores, not 1. And that's defined as part of Python. So if we do that, so we've run it and we don't have a problem. On the other hand, we haven't said anything, so there's nothing coming out, but we don't have any errors. So let's add in some stuff. Let's try and print my car and see what happens. It's not happy. What do you think this means? Main car object at memory location such and such. Any suggestions?
Is it possible to show the code another time, just to double check?
It's just this line 11 here. That's the only change we made, and that's the bit that it's upset about.
Because we have to use the return.
Have to use what, sorry?
Return.
Return. Okay,
Yeah.
possibly. Any other suggestions?
Well, we should write a part in the class which will allow to print a class, and if we don't write it, there is a embedded function. I can't remember how it's called. But
What
yeah,
it's saying
if we
is
don't,
we've tried to print my car, and my car is an object. And what is an object? It's a blob of data describing something. So it's saying it's an object. That's what that's saying. Car is an object. So I don't know what you want me to do. What it does have, though, is attributes. So if I say print mycar.hue, it's quite happy to say blue. Which gives us another clue as to some of the things that we can do with our class. Because it's probably quite common to want to print the details of the object that you've created. So let's think about how we do that. Let's define display, where we simply say print, and copy and paste. Let us define a display function that simply goes through each of the attributes and prints them off. Anything wrong with what I just said?
We can't print them. We have to return them because a print is a one-time only
No.
type of function, and return
No, it's
can
more
go.
subtle than that. What I said was we'll define a function. But what we said was if we are talking about things that objects do in code, they're called a method, not a function. So we're defining a method. So we're defining a method to make it do things, and it's just a simple print. It's not happy. I've still got some red lines. Anybody want to suggest what the red lines are for? Maybe we've forgotten to actually pass anything to this method. So now there's fewer red lines. It's a display function that simply prints off each of the items. So we've still got our two cars. So my car dot, and look what we've got in the pop-up now. Because we've defined the method, in the same way as we can say my car dot manufacturer, we can also say my car dot display, because we have defined the display method. And if we run this now, it didn't work. What am I missing? What am I missing? Because you guys went through this before I did. You guys did this 3 weeks ago. What am I missing? My car dot display self, says Ian. Let's try that. Yep, name self is not defined. It's not that. Any other thoughts?
I think we have to first say that my car as a class has to be defined in there. And then afterwards we can say display.
Well, we have defined it. We've said my car dot becomes car, and then we've said it. And we know that that's worked because we can say print my car dot hue. And it prints blue. Quite happily.
We don't have the
What?
brackets near display.
Okay, I was about to say, what did we always get wrong when we started doing functions way back when? We forgot to put in brackets. And bingo. All of a sudden, when we remember to put in our brackets, we can display the car. And you can see AB12XYZ, blue Ford Focus. And that will work with any of the objects. Your car display. Red, Vauxhall, insignia. We simply forgot the brackets. So these are the sorts of things like the double underscore that always catch me out. The double underscores, the colons, the lack of brackets. So you always have to remember to check all of these things and make sure that, excuse me, and make sure that you've got these done correctly. Because if you don't, then they can cause problems and the output that you get isn't particularly helpful. Because this one didn't even give us an error. This ran, but there was no error message. And the clue comes there, it's going nowhere. Okay, so that's the general idea with objects. We can describe them. We can give them attributes that describe what particular instances look like. And we can give them methods that make them do things. I can set up a new method for a garage that's going to respray cars. And I can send the new color. And I can say self dot hue becomes new color. Okay, so I can set up your car to be red. I can then say your car dot, and look at that. We now have a respray method that's popping up. Respray, and I'm going to make it purple. And then I will print it again. I'll display the new values. So we set it up as a red Vauxhall insignia. We respray it purple. And with any luck, we have a red Vauxhall insignia, and then it changes to a purple Vauxhall insignia. And we can add in as many of these methods as we want to set up this car, or to do things with this car. Anybody get any questions about that? Because that's really what the first lecture was doing. We set up objects. Jerry set up cars as well. He defined them. So he set up cars 1, 2, 3, and 4 as instances of the car object with attributes attached to them. And that was shush. Lecture 1. So did that help, first of all, in terms of covering the material? Was that better than just reading it? Is it worse? Is there something that I could have done extra to help you get through that? Was it worth me doing this, basically?
For me personally, yes.
Okay, thanks, Nikita. If you don't want to come on the mic, just put something into the chat. Or even just give me a thumbs up or a thumbs down from the reactions. Just something so I've got an idea of whether this is worth doing. Got a thumbs up, thank you. Oh, lots of thumbs up. Right, okay, so definitely worth doing then. Okay, that's good to know. Thank you, all right. All right, well, if it's worth doing, that was the introductory object-oriented one. I've just managed to close the second one. That was smart. So we'll go on and look at the next lecture then. Some liked it too. That's good. So let's look at the next lecture in that case.
Now, last week we looked at the idea of Python as an object-oriented.
Why is it so hard to open up the one without the commentary? Am I just particularly stupid today? Don't answer that. Okay, so this is the next one. So we're up to here. We create the class, and then we create some behaviors, which is what I just did. So Jerry's taking you through it, printing out the attributes of the cars as he goes, and then saying, well, okay, rather than doing that, let's have a method that does it. So he's put it in there. And he's done something better than me because, of course, he's put some description in as well, rather than just saying print. So I just did the print just to speed up. I hope you won't be doing that. I hope you will actually add some extra description to help the user rather than just printing. So it should be something like, you know, should be something like that instead. So it actually gives you some information. So he's added in the display all details method, which is what we've just done. And then he's added in more things. Same kind of idea though. Define sound horn. That's all it does. Your car dot sound horn. And if I run that again, it comes up, changes its color, and then beeps, except it didn't. Why didn't it beep? Why didn't it beep? Anybody? Why hasn't it beeped? You've got the attention span of goldfish. What did we forget? Oh, and now it beeps. Yeah, Kerr got there. I don't know if he got there before or after me. I'll assume before, and it just took me a while to come through. So we can get your car to sound the horn. So we can go through and we can add in some methods to, this is meant to be the wipers going, or turning the lights on, or fuel check. And we can work our way through doing things like that. We can say things like, okay, how much fuel is in the car? Self.fuel. We becomes fuel. We're going to need another thing. We're going to add that in and make that part of our initialization. I'm just going to comment this out so I only have to deal with one variable rather than two. I'll get rid of my car and I'll just work with your car. But I'm going to add in fuel, and this time it's going to be a number. And it's going to represent a number between 0 and 100, depending on how much fuel that you have. I'm going to say the car's full when we initialize it. But there we go. There's a variable. Oh, here's the thing though. We added in a new attribute. So now we're going to have to go back and check our methods and say, oh, hang on. Well, one of the things we probably want to do when we're displaying is also show that new attribute, our fuel. Oh, there we go. Now it's coming in. Now that's easy enough to do. I've got a very small program here, 25, 30 lines, only one class. But imagine this on a bigger program where you have multiple classes and lots of methods. Imagine working your way through this, thinking, oh yeah, well, I need to add this in now, and then having to go back through everything that you have there and updating it. How irritating would that be? So this is my cunning way of telling you, don't do it this way. Always, always, always plan it out. So have a bit of paper somewhere that says a car needs to have these attributes. It will need to have these methods. It will need to have, whatever it is. That means that you can program once rather than going through the same loop whenever you think, oh yes, but I also needed. So the planning part is incredibly important. Okay. But what we can then start to do is play with this. So we've got a whole bunch of text things. We've got 100, which is what type of data? What is 100? What kind of data is it? Integer. Thank you, Emma. So what we're going to say is, let's actually work out. So we could define, we could just set fuel tank level in the same way as we said respray. But let's actually do something a wee bit more ambitious. Let's say, let's define a method that says mileage. We'll pass the variable and we will pass distance. My apologies that I'm using mileage. It's just common use here, but in your head you can change it to kilometerage or whatever you want to do. So I probably also want to have a variable that says, an attribute that says mileage, so that I can set up how many miles the car has already done, how many miles on the odometer. And I'll set it up to be 1, 2, 3, 4, 5. And again, you can see how annoying this is. I'm having to go back up, update methods, add in the extra bits that we're suddenly remembering that we need. Thoroughly irritating. Okay, so we've got a new mileage attribute. And now let's think about how we are going to change that. So we could just say we have driven 100 miles. Let's add that onto the mileage. But we can actually be a wee bit more subtle about it. We could say, okay, we have driven a certain amount of distance. So self.mileage, oops, becomes the mileage plus the distance. Lovely. Okay, that should work. So as well as respraying the car, we can say that we are traveling 100 miles in it. Okay, so it's starting off at 1, 2, 3, 4, 5 miles. We travel 100, so hopefully it should come up to 1, 2, 4, 4, 5. So close, and yet so far away. What's the problem? What about if we send self in there? No, self isn't defined. And of course, that self just really means the variable that we're working in, which is your car. This is starting to, oops. This is starting to get more tricky. So how is this going to work? How are we going to work this? Any suggestions? $100 plus 1, 2, 3, 4. I'm not sure what that means. Sorry, self 100 plus 1, 1, 3, 4.
Hear me?
Yeah.
I think so. We get what we have passing to self dot mileage equals self dot mileage plus distance. Either we going to pass two values to the self dot mileage.
Say that again. Sorry.
I was saying that like you have passed self dot mileage equal to values of self dot mileage plus distance.
Mm-hmm.
So to get the value of self dot mileage, we should have two values that we're gonna add.
Well, so we're adding the current mileage to the distance we've travelled and setting that then to the new current mileage. Is it getting confused because we've got a method called mileage and an attribute called mileage? Let's check.
No, it's all right.
We'll call it, let's call it miles instead. Let's try that. Ah, there we go. It was confused. So we've got one object. And the same as when we've worked on this before, we couldn't have two variables called the same thing. How can you? It gets confused. You can't have two things called the same thing. Which one are you actually working with? So in the same way as when we're working here with objects, we can't have an attribute called mileage and a method called mileage because you don't know which one you're working with. So you need to make sure that they are different. So when I change that there, and instead of making it mileage as the attribute and mileage as the method, as soon as I changed it to miles, that worked. So we set it up to be 1, 2, 3, 4, 5 miles. Said that we ran 100 miles, and it then went to 1, 2, 4, 4, 5. So added 100 on. Thing is, though, that's not great. Because you know what I've just noticed? The fuel tank stayed at 100. Presumably, if we have run the tank, then we've used some petrol. So what we could also do is say self dot fuel becomes self dot fuel minus distance divided by 50. So what I'm saying is, for every 50 miles, fuel goes down one amount by every 10 miles, say. So if we drive 100 miles, distance divided by 10 is 10, so fuel should go from 100 to 90. Yeah? Make sense? And if I try that, here we go. We've got our Vauxhall insignia that was at 100 in the fuel tank and 1, 2, 3, 4, 5. We then drove at 100 miles and the fuel tank's down to 90. And it's 1, 2, 4, 4, 5. Oh, and look what's happened to the variable as well. It's gone from an integer to a real number, because as part of our calculation, we did a distance over 10, that gives a real number, so it's swapped that to be real. So it's noticed and updated. Are we happy with this? Is this a proper representation of these cars? The kid is shaking his head, but he's not really sure why he's shaking his head. I'm guessing.
I would just do some design, maybe changes, and that's it, in terms of showing the data in the console.
Okay, you want to just change how it's displayed?
Yeah.
Well, here's the question that I have. We've got a Ford Focus and a Vauxhall insignia. Do they do the same number of miles per gallon? Would a bus do the same number of miles per gallon as a Mini? Would a Bentley do the same number of miles per gallon as a Renault Clio? And if the answer is no, then this calculation that we are making here won't be correct all the time. So it turns out we haven't actually defined our object in as great a detail as we should have done. We're going to need something else. We're going to need the miles per gallon. So when we are setting up our object, we also need to say the number of miles per gallon it does. So our insignia does 10. Our Ford Focus does 20, see? And instead of saying distance divided by 10, we say distance divided by self.mpg. Now, this won't make any difference when I run it. We've still got it going from 10 to 90. But let's bring my car back into play here. And we'll do the same thing with my car as we did with your car. We won't bother respraying it. We'll simply stick to the... So we're setting up my car. It's also driving 100 miles. And it also starts with 100% of fuel in the tank. But because mine does 20 miles to the gallon instead of 10, my Ford Focus has gone from 100 down to 95, where your insignia went from 100 to 90. So it's doing a different thing, getting a different answer, depending on which instance of the object that we run. Does that make sense? And can you see that being useful? We don't have to think about it. We don't have to think about how many miles per gallon it's done. All we say is, well, we've set this up and we'll let it figure out what that means for all of these things. It does mean that we have to be very careful with our models. It does mean that we have to think them through and think about all the things that we need to describe it and all the things that we need to do to change it. But once we've done that, we're doing really well. We can set up another car. And I'll make this as true to life as possible. Not sure if I got the model right. I can't really tell, but I do know it's a Rolls Royce that he drives. It's brand new. It's only got delivery mileage on the clock. And it does a mile per gallon. And it started off with 50% of the fuel in the tank. So we've set up a whole new car. And we can do exactly the same thing. We can send it out to drive 100 miles. So our red Rolls Royce Silver Shadow started at 50, started at 11 miles. It does 1 mile per gallon, we have said. So its new mileage is 111, and its new amount in the fuel tank is minus 50. No. You can't have minus 50 in the fuel tank, can you? I'm almost certain that Bickrant ran out of fuel on the motorway somewhere. So we're not quite there, but you can see how we're starting to add things in. Everything else works, and in fact, that's worked in terms of what we've done. We've just said, well, actually, we can't do it. So what we could do is we could go back to our mileage. And we could say if when we do that calculation, it's less than 0, then we can say that if we do have enough fuel for the journey, then we can do the same calculation. What am I missing out there in the if else? What's it upset about? Why is it not happy with my if statement? Go on, you've been doing these for months. What's wrong with my if statement?
You don't need the brackets, the first ones.
All right. Say that again.
You don't need the brackets, the first brackets in the if.
You don't need the first bracket. Okay. We'll take out that and we'll take out the matching one. Nope, still reds. What's the problem? If you don't know, read it out. Actually, just read it out to yourself. Remember we talked about how sometimes if we talk to people, that helps. Well, talk to yourself. Talk to your teddy bear. Read out that if line and tell me what's wrong. Okay, I'll read it out. If self.fuel becomes self. Wait a minute, becomes in an if statement. Should there be a becomes in the if statement? Why did that happen? Because I just copied and pasted. And it's like, oh, look, I've already got it. I'll just copy and paste. But I ended up copying and pasting the wrong thing. I only need the right-hand side. And all of a sudden, my reds go away. So be careful when you're copying and pasting. It might not be what you expect it to be. But let's see if that's what. So I'll run it. And there you can see we asked it to do 100 miles. It said there's not enough fuel for this journey, and the mileage hasn't changed, and neither has the amount in the tank. Let's, however, check that it does work. Instead of going 100 miles, I'll go 10 miles. And that worked. Our mileage has gone from 11 to 21, and the amount in our tank has gone down from 50 to 40. So all these different types of car, all with different miles on the clock, all with different miles per gallon, all with different distances, all work, and Python knows which one it was and what to do with them because we've set it up. Does that make sense to people? Does anyone have any questions about that? You all happy? Just give me a thumbs up or something so I know, because I'm not getting any feedback at all here.
Yep, very
Let's
happy.
see. Does it help in terms of understanding what's been going on?
Yeah.
Yeah?
Mhm.
See, I knew you had a Rolls Royce background. It was never in doubt. Okay. In that case, the next one is about setting up Cluedo. And the thing in the slide said, create a program to do Cluedo, or Clue, depending on which country you come from. Hopefully you all know how Cluedo works, and if you didn't know how Cluedo works, you looked it up. Now, rather than going through this from the beginning, I should, he says, have one that I did earlier, by which I mean last year. Okay, let's see if we can have a look at a Cluedo program. Okay, so what we have got here is the wrong program. There we go. So, what you were asked to do was to create a class called suspect with the title, the name, location, and then ask it to find out who you are and where you are. So my attempt at that came here. I don't think we need to print hello. So I just created a class called suspect. I initialized it. And you'll see we've got something else this time. So previously the initialization was about setting up the values themselves for each instance of the object. Here what we're doing is saying, actually, for our initialization, we're going to set up a new list. Our list is called suspects, and we're putting in all the characters. Subtly disguised with capital X's in case anybody that owns the copyrights ever looking at this. So it's not really Cluedo, I promise. So we've set up our list with all the possible suspects in it. And then we've said, okay, import random, which gives us a random choice for all the suspects. And it says the suspect's name is a random one from this list. So we've set up our suspects and defined which one it is all in one initialization. Is there anything about that code that you don't understand and want to follow up on? Nope, you all happy? We can then start setting out methods. Get suspect, which is what is simply saying, give us the suspect's name. Really simple. The question said, define methods, who are you and where are you? Okay, we can do that. Define a new method, def, okay. It wanted, who are you? And you can see that Jerry is the underscore type, so I'll follow that. Okay, who are you? And we'll pass the object. And all who are you is going to do is print off some stuff. Print the suspect's name. You probably want to make that nicer. I am. We're done. Def. What was the other one? Where are you? Now here we have a problem. What's the problem that we have? Looking
We
at how
should
we
have
initialize. Sorry?
something. We should initialize in the init function location or something like that.
Yep. So we can do the same kind of idea. Set up the locations. Now, when I'm doing this, you'll see that I'm putting in a lot of white space. There's no need for that white space to be there. It could look like this, and I know that some of you like it looking like this. Thing is, go read a book, and when you open the book, see whether or not there is space between words and space between sentences and all that kind of stuff. And decide for yourself whether or not that makes it easier or harder to read. And if you would be quite happy reading a book where all the words are squashed together, there's no spaces, there's no white space at all, then okay, keep programming like that. If you wouldn't, use white space. actually set it up so that it becomes easy to see. Now that didn't change the function of the locations at all, but it made it easier to read down each of the lists. In the same way, when I'm putting spaces between an equals, it doesn't make it any different, but it makes that becomes stand out. You don't have to look for it in the text. You know that it's a becomes because it stands out there. So please think about that and think about us poor markers that have to look at these things. We can do the same sort of thing here. We can set up a random location. We could just say suspect location becomes locations 1. We can just say that's where they are. Not very good if we've got lots of them, so instead I'll do the same that I did with the name. I'll get a random choice. This time I'll get it from the locations. And now, where are you? We can say I'm in the self dot location. And we can start adding to that. We can set up players which have random setups. We can start showing those. We can set up the player called John, who's turned out to be Colonel Mustard. We can set up a player called Eric, who's Mrs. White. And then we can say P1 dot, whoops, dot yep, so I put it in the right place. So we can say player 1, where are you? And we can say P1 dot, where are you? Not forgetting the brackets. Oops. We forgot to actually set up. So we've said the player name, we've set up the character as a suspect, but that actually didn't include the location. So when we initialized the player, we set up the suspect, but we didn't set the location. So it starts to get trickier. Because we've got multiple classes here. So I'll leave that for you to work out because time is getting on. You want to see how Jerry did it. He did it more simply. He just had one class. It's the same kind of idea as we did last time. 3 attributes, title, name, location. Who are you? Where are you? And he just set them up. All I did was add in some random stuff because it's a game and you want some random in there. and you can start printing off who you are and where you are. Anybody got questions about that? Okay, I'm not seeing anything. In that case, I am done for today. What I think I will do is leave you to work through this Cluedo one, and then we'll finish it off the next time we're doing this, because there's no way I'll get through all this just now. So unless there's any questions, let me stop the recording. As I say, it'll be available from the meeting.